Hello, good evening, everyone. Welcome back to the Gen AI series. So, today our topic would be about memory augmented prompting and context replay. So, let's go through the each slide. So, these are the two techniques redefining how the AI systems they retain and they reuse information. So, traditionally, if we see LLMs are stateless, they forget previous terms once the prompt ends. So, I mean, what happens next? So this leads to hallucinations and loss of continuity in the longer conversations. So with memory augmentation, we can move from short, disconnected interactions towards context-aware assistance. So which remembers, reason, and they adapt. Short context causes hallucinations, long context raises costs. And smart memory, they bring the balance of accuracy, affordability, and scalability. So now we'll go into detail what is memory augmented prompting. As the definition says, memory augmented prompting means attaching an external memory system to the large language model. So rather than feeding the entire conversation history every time, we store key information externally. Then we retrieve only which is relevant before generating a response. So this draws information from human memory. If we see, there are three memory types: episodic memory, semantic memory, and working memory. What is episodic memory? These stores conversational events. Semantic memory stores factual knowledge, like actual facts. Working memory focuses on what is currently important. So these cases include personalization, multi-turn assistance, and long-running automation tasks. So in short, retrieve, enhance, and respond. So, which is exactly represented in this flow diagram, if you can see it. Now, as we understood what is memory augmented prompting, let's move on to what is context replay. While memory augmented prompting, it retrieves past context. Context replay is about re-injecting exact conversation states. So it's more like hitting the replay button on a previous reasoning chain, which is crucial for debugging, audits, or maintaining stateful workflows. So, for example, a chatbot could replay an entire customer conversation to verify consistency or explain a past decisions. So here, memory helps continuity, replay insurance traceability, and reproducibility. So, which are both vital for a trustworthy AI. Now, we shall see what are the practical patterns and implementations of these. Now, if we see RAG plus memory, which means combining both vector bases with metadata to retrieve the information intelligently, retrieve the context. Now, summarize, then store. Compress older conversations into key summarizes to save the space. Third is window management. So this decides which part of the memory to keep or drop. The last one is the replay strategy. So we shall have to choose between selective or full context restoration. So here is a pseudocode snippet, if you can see. So it shows how we embed queries, fetch related memory, merge it with the current user input, generate a response, and update memory only if the result is important. So what does this pattern is making the LLM do? It's making the LLMs more efficient, responsive, and context aware. Now, if we have to see the risks, evaluations, and best practices of these, of course, memory introduces new challenges. Risks are they are incorrect memories, and we do also have a privacy exposure, loss of coherence, and increasing storage costs. And the mitigations would be periodic validation, permissions control, and pruning unused data. So we evaluate performance with metrics like coherence score, context recall rate, and hallucination frequency. Operationally, it's essential to refresh memory, maintain audit logs, and monitor latency. In short, manage memory as carefully as you manage your data quality. So, this is for today's topic. For this more interesting facts and topics, please share, subscribe, and like this video. See you all on the next week. Thank you.